Alright, today you will be learning about the Pythagorean theorem. Why do you need to know this? Well, all of you are in the construction class, so this will be critical to your future in this class. When you're building a building, you need to make sure your corners are a right angle or square. To do this, use the Pythagorean theorem, or later we will talk about the 3-4-5 method. It is important that they are square so that when you're building the building, you have a rectangle or square, not a rhombus.
And first off, I'd like to say I know all you guys are watching on Zoom at home. I'll do my best to show you this board, and then we have another board behind you. If you can't see it, just email me afterwards. I can send it to you. And so all you guys are in high school, so I really hope you know the Pythagorean theorem, but if not, I'm going to go over it real quick, run through it, be good to go. So Pythagorean theorem, a squared plus b squared equals c squared. This only works on a right angle triangle. That means that this angle in the corner here is 90 degrees. And always a squared, a, side B, side C. Side C is always the hypotenuse, which means C is the longest side of them all. So on a triangle, unless it's an equilateral, but that won't have a right angle. Every triangle with a right angle is going to have one side that's longer than the others. It's just always going to happen that way. And so if you calculate this and C isn't correct, that means that this isn't a right angle. So if this is supposed to be 10 and it comes out to be 10.5, your angle's more than 90 degrees. If it's supposed to be 10 and it comes out as 9.5, that means that it's less than 90 degrees. Next, I'll show some examples. These are some already done examples. I'll just run through them here. Side A, side B, side C, triangle. So we're looking for side C. So that means we'll get a squared plus b squared, 7 squared plus 9 squared, 49 plus 81 equals 130. And the square root of 130 is 11.40. So that means side C here will be 11.40. That's another example. We're looking for side C again. So we'll get these two, A and B, square them, add them together. 25 plus 144 equals 169. Square root of 169 equals 13. So that means the hypotenuse, this longer side, will be 13. Same goes for this one. A squared plus b squared equals c squared. You know what's going on. Here's one more example. A little bigger, a little easier to see. So this side is 10 centimeters, this side is 24 centimeters. We're looking for the hypotenuse. They call it X here, you can call it C, you can call it whatever you want, as long as you get the right answer. So 10 squared, 100, 24 squared, 576, add those together, 676, square root equals 26, so this side right here, 26. And I also want to say too, when you're doing the a squared plus b squared, you'll see some that are in inches, some are in centimeters, some are in feet. You can do it in whatever unit you like, it doesn't really matter. And then next, I'm going to go over to the board. We're going to do some examples. Spin our chair here. How about right there? Hope you can see. I'll try to say everything out loud. So this first example is we're looking for C, the hypotenuse. We have 7 and 8. So we'll get 7 squared, that equals 49. I'm writing with my wrong hand here. So we got 49 plus 8 squared, which is 64. Add those together. I didn't even do the math on that. Get 113. Forgot to write that part down. So that equals 113, and we're going to take the square root of 113. And that'll equal 10.63. So C, the hypotenuse, will equal 10.63. You're not always going to get the perfect answer. Like on this one, we got a couple decimal places. Sometimes we get none, if you're lucky. Then we're going to go to this next one. This one's different than the ones we've shown so far. All these ones we've been looking for the hypotenuse, this longer side. This one we're looking for side A here. So it will be a little bit different to do it. So we know these two sides, so we'll do the math for those. 7 squared equals 49. 25 squared, put the square there, equals 625. So for a normal one like this, when we're looking for the hypotenuse, we're going to do a squared plus b squared equals c squared. Since we already know c squared here, and we don't know a, we're going to take c and then subtract 7, or side b, from it. So it'll be 625 minus 49, and that equals 576. Square root of that is 24. So side A equals 24. If you guys want to look at that and write it down if you want to. Just remember, if you're not looking for the hypotenuse, you're not going to add them together. If you add them together, it's not going to work out. Can you see this one, or should we spin the chair a little more?
They can see it.
They can see it all right. So we're into this one as the last one. So this one we know side A, and we know the hypotenuse. So again, you're going to subtract. Usually you can always get the biggest number, which is always the hypotenuse, and subtract the smaller number. You'll get the answer. So we got 12 here. 12 squared equals 144. And then 9 squared equals 81. Everybody got that so far? And then we are going to subtract. A little subtraction sign there. That equals 63. And then we're going to square root that. And that'll equal 7.94. So that's saying this side B will be 7.94. Self-explanatory? Alrighty, we will go back to the board and I will talk about 3, 4, 5. So 3, 4, 5 is what a lot of people in the quote-unquote industry, you could say, do. It's basically 3, 4, 5 is right triangle. So if one side's 3, one side's 4, the other side will be 5. If it's right triangle, it's always the same. So here's all 3 versions of it. This first one, we know the hypotenuse. We know this side, they call it G. You could call it B, whatever. So they will get 5 squared minus 4 squared equals 9. Square root of 9, 3. Same goes for this one. 5 squared plus 3 squared equals 4 squared. Same, and then this one is normal hypotenuse you don't know. So 3 squared plus 4 squared equals 25. Square root of 25 equals 5. Here's another picture of the 3, 4, 5. Goes into a little bit more depth, a little bigger so you guys could see it. You couldn't see the other one. A squared plus b squared equals c squared. If it's right triangle, it always works. And then this is a picture of how they use it in real life. So here, what is that? Is that the sign for inches or feet? Feet? All right, so here they're using 3 foot, 4 foot, 5 foot. So this is their corner, and whatever you can pretend what it is. So they'll measure out here from this corner out to 3 foot. They'll either put a mark there, they can leave their tape measure there, do whatever they like. And they can measure this side or this side, whatever first, but usually measure this side, maybe make a mark, and measure between those 2 marks, and if that's 5, you're solid. And then I'm going to show an example real quick. First I want to say this method works for anything that you're building that has corners or anything that already has corners. You can do this anywhere. An example of how I used it was I was building a set of backboards, and if it's not perfectly straight, if everything's not square, when you set that piece of plywood on top, it's going to hang off on some sides, it's not going to go off on some other sides. That's usually how it works. And yeah, so I'm going to teach you, I'm going to show an example of the 3, 4, 5, and then I'm going to show an example of just normal Pythagorean theorem. And I'll come closer to the camera so you can see here. I put numbers on it so you can see a little better. So can you see it in frame? You don't need to see it.
Yeah, you can see it.
So this is your corner here. I put these black pieces of tape so you can see it better. So this side you're going to measure out 3 inches. And not 3 inches, so that side's 3. This side you're going to measure out 4. Measure out 4. Then you measure between these 2 points, here and here. You measure between that. Hold it upside down. 5. It's hard to see, so is it upside down? Maybe I'll try it this way. It's still hard to see, but it's 5, I'll tell you that. So then that's 3, 4, 5, and then I'll show it just this whole piece. So if you measure out from here all the way to the end, it'll come out to be 9 5/16. I have it written on top if you want to take a gander at that. And then on this side, you measure out, it'll be 10.5. So you'll get the math there. So 9 5/16, that's also 9.3125 inches. You're gonna square that, that'll equal 86.7226. And then on this side, 10.5, that equals 10.5. And then if you square that, that'll equal 110.25. And you square that number, add it together. If you add them together, 196.9726. Square root that equals 14.3. So just a hair over 14. And if you measure between there, it is just a hair over 14. And then I have this also to prove that it's a angle. It's like a square. Boom. Perfect 90 degrees. And now Mr. Snyder will go over all the homework you guys have for this unit, and then also the final, what'll be on it, and cover all that.
All right. Now it is time for the activity, because the best way to learn something is to practice it yourself. How about that tape measure? For this activity, you will be practicing the 3-4-5 method. A couple things to point out is that, like he said, you can use any unit of measurement. That being said, you can also scale it up. So say you're doing something really big, you can do the scale it up by a factor of 2. It would be the 3-8-10 or 6-8-10 method, or a factor of 3, it would be the 9-12-15 method. So what we will be doing at home is you'll be going around your house and finding 5 corners that you think are supposed to be a square or right corner, and you will be using the 3-4-5 method to find out whether or not they actually are. So right here, I will do an example. To me, this looks like it's supposed to be a right angle, but let's make sure of that. So you get out, you get your tape measure and a marker or other things, and you're gonna measure out from the inside here, measure out, and we get our 4 inches marked right there. Then we're gonna measure up, and you have your 3 inches right there. And then you're gonna take it and you're gonna measure across. Alright, let's see this pretty well.
Yeah, let me grab this. I'll scoot way forward here.
As you can see, between my 2 marks, it's right at 5 inches. So you can tell that that would be a right angle. Now, let's implement it a little bit larger. We will scale it up. Instead of using inches, we'll do feet. So for this, you're gonna take, instead of doing 4 inches, you'd measure 48 inches, which is 4 feet, which would take you off the edge, but over into here. And then you're gonna measure up your 3 feet, 36 inches, from that same corner, which will bring you up to here. And then you can measure across. Now this shows that it is just under 5 feet. So like I talked about before, when you have something fairly large, you may not want to use 4 inches and 3 inches, because this showed me that it was in fact square, but when I measured out farther, it showed that it was actually under 90 degrees. So you'll go around your house and you'll find 4 other corners, and then take pictures of them and write down whether it was square or not, and whether you think it's a big deal that it is square or not, and then you will email that to either me or Clay. swing it around. After you've done that take-home assignment, we'll be getting ready for your unit test. This test will be sent over to you. It'll be over the Pythagorean theorem and the 3-4-5 method. If you do the practice problems we've done and the take-home assignment, you should be set up perfectly for this test. Do you have anything? If you have any questions, you can email it to either Clay or myself.
Just one thing to add on, just so you guys don't forget, like I said earlier, if you're doing the 3-4-5, one side's 3, and if one side's 4 and the other side is 5 1/4, or it's 4 1/2, that means it's not a 90-degree angle. That's just the last thing I'd add on. But yeah, the first section will be over the Pythagorean theorem, what I talked about, and then the second section will be the 3-4-5, what he talked about. After you're done with that, send it to us, and you'll be all good.